Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video we're going to be looking at the 2019 Sydney Tech Year 11 final exam. I'm going to be attempting this for the first time, so hopefully I don't get anything wrong. This will be like watching me attempt this live, so you know maybe what speed you should go at. Maybe I'll probably be going at my speed, which will be faster than you, potentially. So just so that you know. Okay, let's have a look at multiple choice. Question 1. If A is equal to 1 minus 2c, in which expression has c been correctly made the subject? So for question 1, we have A is equal to 1 minus 2c. 2c is equal to 1 minus a. And so c is equal to 1 minus a all over 2. That's B. Question 2. In a raffle, 30 tickets are sold and there is one prize to be won. What is the probability that someone buying 6 tickets wins the prize? So this person has 6 chances out of 30. So that's 1 out of 5. A function is given by f of x is equal to root 4 minus x squared. What is the natural domain? So here we know, because it's underneath the square root sign, that has to be greater than or equal to 0. We can't square root a negative number. So I'm going to move the x squared to, actually I'll move the 4 across. Negative 4. I'll divide both sides by negative 1. That changes the sign to positive 4. And then we can work this one out. We know x squared, this one here, actually it might be better if we actually make it x squared minus 4 is less than or equal to 0. This factorizes to x plus 2, x minus 2 is less than or equal to 0. So that means I know my x-intercepts will be at minus 2 and at 2. Minus 2 for this one, positive 2 for that. And then I'll just graph it. So we have x squared. So it's going to be concave up. And because here it says it's less than or equal to, so it has to be underneath the x-axis. So it needs to be between minus 2 and 2. So the answer is C. Question 4. If 5 root 2 minus root 8 plus root 32 is equal to root x, the value of x is, so we have 5 root 2 minus, I can simplify that as root 4 times root 2, and I can simplify this as root 16 times root 2. Or 5 root 2 minus the square root of 4 is 2. So 2 root 2 plus the square root of 16 is 4. So 4 root 2. That leaves me with 3 plus 4 is 7 root 2. Now there's nothing in front of this. It's just a 1. So we need to put this 7 underneath the square root sign. So we need to times the 2 by 7 squared. So that has to be root 98. 2 times 49 is 98, so the answer is B. Question 5. The graph of y equals 1 minus x cubed could be, well, we know that x cubed looks like that, so minus x cubed has to look like this. And because it's going up 1, so originally it'll look like that, but it's going up 1, so it's going to look something like this. Let's see. Question 6. What is the derivative of x squared minus 7 to the power 4? So if we want to differentiate this, we bring down the power, we write down everything the same. Bring down the power by 1, but we need to times it by the derivative of what's inside the brackets. When we differentiate that, we get 2x. Okay, so this is the chain rule. So 8x bracket x squared minus 7 cubed. C. What is the period of y equals sine 2x? So the period is equal to 2 pi over the coefficient of x. The coefficient of x is 2, so the period is just pi. B. Question 8. The diagram shows the line L. What is the slope of the line L? Now the slope is the gradient, which we associate with tangent, because tangent is opposite over adjacent, which will be rise over run, which is the gradient. So that means the gradient is pretty much just tan of 60. Tan of 60 is the same thing, sine 60 over cosine of 60. And so if we were to do our unit circle, 60 degrees is up here, and it has coordinates half root 3 on 2. The first one being cos, the second one being sine. So sine 60 will be root 3 over 2, over cos 60, which will be 1 over 2. So the 2's cancel each other out, we're left with root 3. However, because this line is sloping down from left to right, it has to be negative. So the answer is D. Question 9. Simplify 2 log 10 minus log 5 and choose the correct answer. So 2 log 10, we can rewrite that as log 10 squared. So it's like reversing it. Using the log law, normally we would bring down the power, but here we're reversing it. We're putting this 2 back up as the power, minus log 5. So technically that's log 100 minus log 5. And we can use our log laws to make it one simple log, which is equal to log of 20. C. Last question for multiple choice. What is the solution to the equation 2 sine 2 theta minus 1 is equal to 0 for 0 is less than or equal to theta, which is less than or equal to 360. So I'm going to move this one across to get 2 sine 2 theta is equal to 1. And then I'm going to get sine 2 theta is equal to half. Divide both sides by 2. Now because of this 2 theta, it's actually going to change the domain to 0 is less than or equal to 2 theta, which is less than or equal to 720, because we need to multiply each of these by 2. Each of these by 2, so we can get the 2 theta. So that means that the angle 2 theta will equal to inverse sine of half. Inverse sine of half is 30 degrees. So if I were to graph my all stations to central, we know it's 30 degrees here. But where else is sine positive? Over here. So that's 30 degrees as well. So it's 30. It's also 180 minus the 30, which is 150. And then because of the new domain, we need to add 360 to each of these. So 30 plus 360 is 390. 150 plus 360 should be 510. And therefore theta is equal to, because this is 2 theta, we're going to divide each one of these by 2. 15, 75, 195, and 255. So the answer is D. Okay, so that's it for multiple choice. Let's have a look at question 11. Evaluate cosine 92 degrees over tangent 130 degrees, correct to 3 decimal places. (0.029). Factorize 2x squared minus 5x minus 3. So I'm going to multiply my 2 and minus 3 to get minus 6. And the two numbers that multiply to negative 6 but add to negative 5 are minus 6 and 1. So I've got 2x squared minus 6x plus x minus 3. I just replaced minus 5x with this because that's exactly what it is. Got that from there. Now I can factorize by grouping in pairs. I'll take out a 2x, leaving me with x minus 3 here. Write down my plus sign, and I still have an x minus 3. This now factorizes to x minus 3 to x plus 1. Question C. Express 495 degrees in radians. Leave your answer in terms of pi. So in order for us to convert degrees into radians, we just divide the angle by 180. So that leaves me with 11 pi over 4. Question D. Find the exact value of sine 2 pi over 3. I like to convert this to degrees. So 2 times 180 over 3 is 120. So technically we're doing sine of 120 degrees. Sine of 120 degrees means that this has to be 60. So this has to be 60. And because it's positive, it's just going to remain positive, sine of 60 degrees. So using our unit circle, I know 60 degrees is half root 3 on 2, and sine is root 3 on 2. Now we can double check this. If I were to put this in, actually we can just leave it sine 120, 0.866. And if I were to do root 3 over 2, yeah, get the same answer. Okay. Question E. Solve the absolute value of 2x plus 1 is equal to 3. So that means 2x plus 1 has to equal to 3, or 2x plus 1 has to equal to negative 3. I'm going to solve these two equations. So 2x is equal to 2, x is equal to 1, 2x is equal to negative 4, x is equal to negative 2. Question F. Rationalize the denominator of 2 over root 5 minus 1. We need to multiply by the conjugate, root 5 plus 1 over root 5 plus 1. I find it helpful to put brackets. So we've got two lots of root 5 plus 1 over, here we've got a difference of 2 squares. Root 5 squared is just 5, minus 1 squared is 1. So technically that's 4. And now we can just simplify that to root 5 plus 1. Right, proper 5 over 2. Question G. I should put it over here. Solve 2x plus 3y equals 28 and 3x plus 2y equals 27 simultaneously. Okay, so here's my statement 1, here's statement 2. I'm going to multiply statement 1 by 3 to get the coefficient of x to be 6, and I'll multiply statement 2 by 2 to get the coefficient of x to also be 6. So that's going to give me statement 3, and this will give me statement 4. So statement 3 will be 6x plus 9y is equal to 28 times 3, 84. Statement 4 will be 6x plus 4y is equal to 27 times 2, that's 54. I can now subtract, so 9y minus 4y is 5y, 84 minus 54 is 30, so y has to equal to 6. Not done yet, still need to work out what x is equal to. I'll sum that into the first one. So we have 2x plus 3 lots of y, which is 6, is equal to 28. Or 2x plus 18 is equal to 28. 2x is equal to 10. X is equal to 5. Done. Okay, question 12. Fully factorize x cubed plus x squared y minus x minus y. So I'm going to group in pairs. Group them together, or group these two together. So that leaves me with x squared bracket x plus y minus bracket x plus y. I know it says minus here, but this minus sign times a positive will give us a negative. That allows us to factorize this to x plus y, x squared minus 1. However, this is not fully factorized because this is a difference of 2 squares. So that leaves me with x plus y, x plus 1, x minus 1. Question B. Simplify 2x squared over x squared minus x minus 2 times x minus 2 over 6x. So we've got 2x squared over, I'm going to factorize this now. So that's a monic quadratic trinomial that factorizes to x minus 2, x plus 1. I'm going to multiply that by x minus 2 over 6x. So these will cancel each other out. And x will cancel out with that x, and the 2 will cancel out with this, leaving us with 3 down there. So that leaves me with x in the numerator over 3 lots of x plus 1 in the denominator. Question C. Differentiate the following. Y is equal to negative 6x cubed plus 4x squared plus 3. So y dash has to equal to negative 18x squared plus 8x. Bring down the power, reduce the power by 1 for all x's. That's part 1. Part 2. We have y is equal to 3 over x to the power 4, which I'm just going to rewrite as 3x to the power negative 4. So y dash has to equal to negative 12 x to the power of negative 5, because we need to reduce the power by 1. I'm going to rewrite this without the negative power. Okay, question D. Evaluate the limit as x approaches 4 for x squared minus 16 over x minus 4. So the limit as x approaches 4, I'm going to factorize the numerator right now. That's the difference of 2 squares, leaving me with x plus 4 over x minus 4, all over x minus 4. So that cancels each other out, leaving me with the limit as x approaches 4 for x plus 4, which will be 4 plus 4, which is 8. Question E. Find the equation of the line that passes through to point 5 minus 7 and is perpendicular to the line y equals minus 5x plus 2. Leave your answer in gradient intercept form. Okay. passes through that perpendicular to this line. So that means I know that the gradient that I'll be using will be positive 1 over 5. So y minus y1 is equal to m bracket x minus x1. We'll use the point gradient formula to work out the equation of line. This is our x1, here's our y1. So y minus 7 is y plus 7. The gradient we'll be using, which is perpendicular to that, is positive 1 over 5. X minus x1, which is 5. I am going to expand the brackets. And now I'm going to subtract 7 from both sides. And that's my answer in gradient intercept form. Question 13. Differentiate f of x is equal to f of x is equal to root x squared minus 5. So I'm going to rewrite this as x squared minus 5 all to the power of half. And I'm going to use the chain rule. F dash of x is equal to bring down the power. Write everything inside. Reduce the power by 1. And then I'm going to times this by the derivative of what's inside the brackets, which is 2x. Now that half will cancel out with that 2, leaving me with x at the top, and I'm going to bring this all down to the denominator and leave it with a positive power of half. Question B, part 1. Consider the function y equals x squared plus 4x plus 6. Find the value of the discriminant. Okay, so the discriminant is b squared minus 4ac, is the bit underneath the square root sign of the quadratic formula. So b is 4, a is 1, and c is 6. Minus 8. Find the coordinates of the vertex. So just so that you know what this means, because the discriminant is negative, that means there will be no x-intercepts. The coordinates of the vertex. So the x-coordinate will be minus b over 2a. So minus 4 over 2 lots of 1, which is minus 4 and 2, which is minus 2. And the y-coordinate, we're going to sub that in. So we've got minus 2 squared plus 4 times minus 2 plus 6. Minus 2 equals. So we've got answer squared plus 4 answer plus 6, which is 2. So therefore the vertex is minus 2, 2. Okay, here's our x, here's our y. Minus 2, 2. Part 3. Sketch the graph showing all important features. Use at least 1/3 of a page. Wow, okay. So we found a discriminant, we know there's no x-intercepts. We found the vertex. The only thing we need left is the y-intercept. So the y-intercept is going to be 6. Okay, so let's graph this. Let's just say that's about 1/3 of a page. Y-intercept is minus 2, 2. Minus 2. Let's say that's 2. Y-intercept is 6. 2, 4, 6. And now we can graph that parabola. Make sure you label your vertex minus 2, 2. I'm going to just make it a little bit neater. Okay. State the range. The range is all the possible y values. So it's from 2 to infinity. sorry, I'm going to write range y is greater than or equal to 2. If you want to write an interval notation, you can. It's from 2 to infinity. We use the square bracket for 2 because we do include the 2, but we always use code for infinity. Alright, question C. Given that sine x is equal to 3 over 7 and tan x is negative, find the exact value of cosine x. Okay, so what I would do here is I would draw my all stations to central. Okay, sine is positive, but tan is negative. So where is sine positive and tan negative? It's only in quadrant 2. Alright, now because this is saying that sine of x is equal to 3 over 7, so opposite over hypotenuse, we can now use Pythagoras' theorem to work out this other side. So the other side is 49 minus 9. So it's root 40. Square root of 40. Okay. Square root of 7 squared minus 3 squared. Alright. We need to work out the exact value of cosine x. So here, cosine of x is adjacent, which is root 40 over hypotenuse 7. But in this quadrant, only sine is positive, so this has to be negative. I might just simplify this because I can simplify the third. That's going to equal to negative 2 root 10 over 7. But I'm pretty sure you'll get the answer correct if you just did that, if you left that as the answer. Question D. A packet of lollies contains 5 red lollies and 14 green ones. 2 lollies are selected at random without replacement. What is the probability that the 2 lollies are red? Okay, so here, I would like to do a tree diagram. So it's either red or green, and then red or green, red or green. There are 5 out of 19 lollies that are red. If you were to pick one, now there's only 18 left, and there's only 4 red ones if you first took a red. There are 14 out of 19 to begin with. If you select a red next, there's still 5 left out of the 18. But if you took a green the first time, there's only 13 left now. So the probability that the 2 lollies are red, maybe I'll do this, probability that they're both red is 5 out of 19 times 4 out of 18. Which is 10 over 171. And that's for part 1. Part 2. What is the probability that the 2 lollies are different colors? So the probability that they are different colors, well, you can either get red and then green. Oh, I forgot to fill this one out. So this one is still 14 over 18. So it'll be probably that they are different colors. Is the probability that you get red first and green, plus the probability that you get green first and then red. So the probability that you get red first and green is 5 out of 19 times 14 over 18. And the probability that you'll get green first is 14 out of 19, and then red is 5 out of 18. So we put that in our calculator. Plus 70 over 171. Alright, so that's the end of question 13. Let's have a look at question 14. Differentiate with respect to x. X squared times 2x plus 1 to the power 5. Fully factorize your answer. So here, what we need to do is we need to use the product rule. So u is x squared, so u dash is equal to 2x. V is equal to 2x plus 1 to the power of 5. So v dash, we need to use the the chain rule here. Bring down the power, reduce the power by 1, but times it by the derivative of what's inside the brackets. So that simplifies to 10, 2x plus 1 to the power of 4. So if we want to differentiate this, d dx of x squared times 2x plus 1 to the power of 5, that's equal to vu dash 2x times 2x plus 1 to the power of 5 plus uv dash. That gives us 10x squared bracket 2x plus 1 to the power of 4. Now the question says we need to fully factorize our answer. So I'm going to bring out 2x and 2x plus 1 to the power of 4. That leaves me with one lot of 2x plus 5 here. 2x plus 1. And it's going to leave me with 5x here. I'll just tidy that up. So leave me with 7x plus 1. Alright, that's question A. Question B. Find dy dx given that y is equal to x minus x squared over 5x plus 1. So if y is equal to x minus x squared over 5x plus 1, if we want to differentiate this, we need to use the quotient rule here. So u is equal to x minus x squared. So u dash has to equal to 1 minus 2x. V is equal to 5x plus 1. So v dash has to equal to 5. So y dash is equal to vu dash minus uv dash all over v squared. I wonder if that's enough, or whether you need to expand and simplify. Let's expand and see what we get. So we expand this, we'll get 5x minus 10x squared plus 1 minus 2x minus 5x plus 5x squared all over the 5x plus 1. Remember, we don't ever need to expand the denominator. Just leave it factorized. Right, so this leaves us with minus 5x squared. Okay, those cancel. Left minus 2x plus 1 all over 5x plus 1 all squared. I'll probably make that my final answer. Question C. Find the equation of the normal to the curve y equals x cubed plus 4x plus 7 at the point where x is equal to 1. Leave your answer in general form. So in order for us to work out the gradient of the tangent, we need to differentiate. So y dash is equal to 3x squared plus 4. We want to know the gradient when x is equal to 1. So when x is equal to 1, the gradient of the tangent is going to equal to 3 times 1 squared plus 4. That's going to equal to 7. Now the question wants us to work out the equation of the normal. So therefore the equation of the normal has to be equal to the negative reciprocal of that, which is negative 1 over 7. Okay, now in order for us to work out the equation of the normal, we need a point. We don't have a point yet. We've got x equals 1. So we need to know what y is equal to when x is equal to 1. So when x is equal to 1, y is equal to 1 cubed plus 4 lots of 1 plus 7. Okay, just subbing it straight into the equation. 1 plus 4 is 5 plus 7 is 12. So that's the point we'll be using, 1, 12, x and y. Sorry, x1, y1. So the equation of normal is y minus y1 is equal to m bracket x minus x1, which should be a 1, not a 12. And what does the question say? Leave your s in general form. Okay, so I might multiply everything by 7 first to give me 7y minus 84 is equal to, and then expand the brackets, negative 1 times x is negative x, negative 1 times negative 1 is positive 1. General form means we need everything equal on one side, make it equal to 0, positive x and no fractions. So because x is negative, I'm going to move everything on that side to that side, leaving me with positive x plus 7y minus 84 is equal to, sorry, not 84, 85, because we need a minus 1, and that's equal to 0. Okay, question D, part 1. On a Cartesian plane, draw a neat sketch of the function y equals f of x, where f of x is equal to x squared minus 4 for x is less than 2, and 4x minus 8 for x is greater than or equal to 2. Alright, so I know x squared minus 4 looks something like this. So here's minus 4. I know it's going to look something like this. But we're only going to be drawing it up to when x is equal to 2. So technically, what is y when, what is f of 2? It'll be 2 squared minus 4, which is 0. So it's going to approach 0 when x is 2. Okay. 4x minus 8, I know that is a straight line. But when x is 2, what is y equal to? 4 times 2 minus 8. Well, that's also 0. So it's going to start here. Let's just do f of 4 now. F of 4 will be 4 times 4 minus 8. 16 minus 8 is 8. So I know when x is 4, it's going to go to 8. It's going to be a straight line. Alright, so let me see if I can make this neater. Okay, so let's say that's minus 2, minus 4. Say that one's minus 2, minus 4, 2, and 4. Two, 4, 6, and 8. That's a straight line. Is the function differentiable at x equals 2? Justify your answer. I would say yes. Because it looks like it's continuous and it's smooth. Alright, question 15. How many questions are there? 16 and 17. 18 and then an exam. Okay, almost there maybe. Alright, Question 15. The number of bacteria in a culture increases according to the function b is equal to 2t to the 4 minus t squared plus 2000, where t is time in hours. Find the number of bacteria initially. So initially is when t is equal to 0. Should we make this part 1? Oh, 2 times 0 to the power 4. That's going to equal to 2000. Find the rate at which the number of bacteria is increasing after 5 hours. So in order for us to work out the rate, we need to differentiate the number of bacteria with respect to time. That's going to give us 8t cubed minus 2t. So when t is equal to 5, because the question says 5 hours, the rate is going to be 8 times 5 cubed minus 2 times 5. And that's equal to 990 bacteria per hour. Okay, part B. Part 1. Given that log base b of 2 is equal to 0.43 and log base b of 3 is equal to 0.68, evaluate log base b of 1.5. Now log base b of 1.5 is technically log base b of 3 over 2. We can use our log laws to separate them. Log base b of 3 minus log base b of 2. Log base b of 3 is 0.68. And log base b of 2 is 0.43. So that gives me an answer of 0.25. Part 2. Log base b of 2 root 3. I'm going to separate that into log base b of 2 plus log base b of root 3. But I'm going to rewrite root 3 as 3 to the power half. We can continue using our log laws to bring this power down. And therefore we've got log base b of 2 is 0.43 plus half times 0.68. Which is here, 0.77. Okay, part C. Part 1. Mr. H tries to connect his internet service provider. The probability that he connects on any single attempt is 0.75. What is the probability that he connects for the first time on his second attempt? So that means he must have failed the first time. So the probability that he failed and then he succeeded has to be 0.25, because the probability he failed is 0.25 times 0.75, which is the probability he succeeded on the second attempt. Which is 3 on 16. Part 2. What is the probability that he is still not connected after his third attempt? So that means he must have failed, and failed. 0.25 cubed. One out of 64. Okay, question D. Differentiate f of x is equal to x squared minus 3x from first principles. So first principle says the limit as h approaches 0 of f of x plus h minus f of x is all over h. Okay, so wherever there's an x, we're going to replace it with x plus h. minus 3 lots of x plus h, and then we're going to minus f of x, all of that, x squared minus 3x. Okay, let's expand and simplify. X squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x all over h. X squareds cancel each other out. Minus 3x and 3x cancel each other out. So we're left with the limit as h approaches 0 for, and I'm going to just take out the h straight away. Factorize out the h. Oops, not a 3, a h. That leaves me with 2x plus h minus 3 all over h. The h's will cancel. And now I'll apply the limit as h approaches 0. So as h approaches 0, we're left with 2x plus 0 minus 3, which is 2x minus 3. Okay, 16. The diagram shows a sector AOB, the length OA is 6 centimeters, and angle AOB is equal to 5 pi on 12. The points C and D lie on OA and OB respectively, and OC equals OD. Find the exact area of sector AOB. Okay, so the area of a sector is equal to half r squared theta. The radius here is 6, and the angle is 5 pi on 12. Now this wants the exact area, so I'm not going to type pi in my calculator. I'll just do half times 6 squared times 5 over 12. So that leaves me with 15, and then I'll put the pi at the top. 15 pi over 2 square centimeters. Part 2. If the area of triangle COD is half the area of sector AOB, find the length of OC, correct to 2 decimal places, let OC equal to x. Okay. So if what we need to do is we need to work out the area of triangle COD. We know that's half AB sine C. In this case, A and B are both x's, so it's half x squared sine of 5 pi on 12. And we know that that area is going to be half of this, the area of the sector. So we need to work out the length of OC. So if half of x squared sine 5 pi on 12 is equal to half of this, well, half of that is 15 pi on 4. Let's see what x squared is equal to. So I'm going to get rid of that half. So x squared sine 5 pi on 12 is equal to 15 pi on 2. I'm going to divide both sides by sine 5 pi on 12. So x squared is equal to 15 pi on 2 over sine 5 pi on 12. And then we'll need to square root it. Now this says correct to 2 decimal places. Okay. So x is equal to the square root of all of that. Okay, I'm going to put my calculator in radian mode because here I've got pi. So, and I'm doing trig, so it needs to be in radio mode. So shift mode 4. Alright, so we've got the square root. I'm going to have 15 pi over 2 over sine of 5 pi over 12. .94. Using at least 1/3 of the page, draw a neat sketch of the function f of x is equal to all of those. Label all x-intercepts. So question B. I know that the x-intercepts will be -1, 2, and 4. My y-intercept is when x is equal to 0. So we have -1 times 1 times -2 times -4. -8. And because it's -x cubed, I know it's going to look like this. Okay. -1, 2, and 4. And we'll just label that -8. Okay. So it's going to look something like this. And that's good enough. I don't think we need the turning points. I think that's year 12 work. Question C. Prove that tan theta plus cotan of theta is equal to secant theta cosecant theta. So let's look at left hand side. Is equal to sine theta over cosine theta plus cosine theta over sine theta. But then we'll cross multiply and get the same denominator. So that leaves us with sine squared theta plus cos squared theta all over sine theta cosine theta. Using the trig identity, we know sine squared theta plus cos squared theta is equal to 1. And now we can split this up. 1 over sine theta times 1 over cosine of theta, which is equal to 1 over cosec. Sorry, not 1 over. It is cosec theta, and this one will be sec theta, which is equal to the right hand side as required. Question D. Let f of x equal to 1 over root x and g of x is equal to x squared plus 2. Find f of g of x. So f of g of x means we are going to replace all x's in f with whatever g of x is. So we've got 1 over the square root of x squared plus 2. I'm not sure you have to simplify that. No, I think that's it. Can't simplify that. Okay, part 2. Determine whether the composite function from part 1 is odd, even, or neither. Justify your answer. Okay, so when we replace x with negative x, no, what we need to do, okay, so if f of let's call this h of x. H of x is equal to 1 over root x squared plus 2. What is h of negative x? 1 over the square root of negative x squared plus 2, which is still 1 over root x squared plus 2. So that's technically equal to h of x, and therefore the composite function is even. As h of x is equal to h of negative x. Okay. Question 17. "80 people were surveyed to find out how many of them had visited the cities of Barcelona and Prague. The survey showed that 23 people had visited Barcelona, 18 Prague, and 10 had visited both. What is the probability that a person chosen at random has visited Barcelona and Prague, only one of the two cities, and neither city?" So A, part 1, part alpha, Barcelona or Prague. So I think the easiest way to do this is to actually do a Venn diagram. Don't forget your rectangle on the outside, and don't forget to label. So we've got Barcelona and Prague. 10 people had visited both, so that goes in the middle. 23 people had visited Barcelona, so 23 minus 10 is 13. And 18 people had visited Prague, so 18 minus 10 is 8. So what number goes on the outside? We've got 13 plus 10 plus 8. And 80 people were surveyed, so 80 minus that is 49. Okay. The probability that a person chosen at random has visited Barcelona or Prague, Barcelona or Prague, has to be everything inside the brackets, so 23 plus 8 is 31 out of 80. Okay, part B now. Only one of the two cities, 13 plus 8 is 21 out of 80. And this symbol, I can't remember what it is, neither city, that's just 49 out of 80. Alright, part 2. Find the probability that a person has been to Barcelona, given that they have been to Prague. So Barcelona, given that they've been to Prague. So that means it's out of all the people who have been to Prague. 18 people have been to Prague, and out of those 18, only 10 have been to Barcelona. I'll just simplify that. Question B. Solve 2 cosine squared x plus cosine x is equal to 1 for that domain. So I'm going to move the 1 across to leave us with 2 cosine squared x plus cosine x minus 1 is equal to 0. I'm going to let u equal to cosine x. So that means I've got 2u squared plus u minus 1 is equal to 0. And now I'm probably going to factorize this. So I'm looking for two numbers that multiply to negative 2, but add to positive 1. Positive 1. So that will be 2 and minus 1. So 2u squared plus 2u minus 1 is equal to 0. So I just replace this plus u with plus 2u and minus 1u from here. I'll now group this in pairs. 2u bracket u plus 1, put a minus sign, bracket u plus 1 is equal to 0. That leaves me with u plus 1, 2u minus 1 is equal to 0. Therefore, u has to equal to negative 1 or positive half from here. Well, u was cosine x, so cosine x has to equal to negative 1, or cosine x has to equal to positive half. So therefore x has to equal to the inverse cosine of negative 1. Let me put this back into degree mode. Cosine x, inverse cosine of negative 1, it's 180 degrees, which I know because the domain here is in radians. That's just pi radians. And x is equal to the inverse cosine of half. But remember, we need to think about where is cosine positive. Here and here. So the inverse cosine of half is 60 degrees. So that's 60 and this one 60. So in this domain from 0 to 2 pi, we know it's 60 degrees and 360 minus the 60, 300 degrees. I will now convert that to radians. So 60 divided by 180 is pi on 3 radians. And 300 over 180 is equal to 5 pi on 3. Okay, so these are our final answers. Question C. Solve 2 to the 2x is equal to 5 to the x minus 1. Alright, we'll probably have to use logs here. So if I were to take the natural log of both sides, ln of 2 to the 2x is equal to ln of 5 to the x minus 1. We can now bring down the powers, so we get 2x ln of 2 is equal to x minus 1 ln of 5. I might divide both sides by ln of 2. Let me see. Actually, you know what, let's see. What happens if I expand this? If I were to expand this brackets, I'll get x ln 5 minus ln of 5. If I were to bring this x ln 5 across, that will leave me with 2x ln of 2 minus x ln of 5 is equal to negative ln of 5. Factorize out an x, leaving me with 2 ln of 2 minus ln of 5 is equal to negative ln of 5, and then divide both sides. Negative ln of 5 over 2 ln of 2 minus ln of 5. Alright, leave your answer correct to 2 decimal places, so let's hope this works. Negative ln of 5 over 2 ln of 2 minus ln of 5. 7.21. Let's just see if this works. I'm just going to double check my answer. So 2 to the power of 2 times 7.21. That's about 21,920. And if I were to do 5 to the power of 7.21 minus 1, yeah, very close. 21,920, yeah, I'll accept that. Alright. Question 18. This is the last one. Yes, good. Alright. Last question. A part 1. In a game, A turn involves rolling 2 dice, each with faces marked 0 to 5. The score for each turn is calculated by multiplying the two numbers uppermost on the two numbers uppermost on the dice. What is the probability of scoring 0 on the first turn? Okay, so in order to score 0, at least one of the there's 36 different outcomes. Of those that multiply to 0, there would be 12 of them. Is that correct? Because you can have 0 and 0, 0 and 1, 0, 2, 0, 3, 0, 4, 0, 5, or the second one being 0. Was that only 11? Maybe it's best if we draw an array. So if we have 0, 1, 2, 3, 4, and 5. 0. Oh, maybe we'll make this one 0. 1, 2, 3, 4, 5. All of these when multiplied together will equal to 0, and all of these when multiplied together will equal to 0, and that's 11. Okay, so that's 11 out of 36. Part 2. What is the probability that the sum of the scores in the first 2 turns is less than 45? Okay, so that means we need to work out. Why don't I write down what the product is of each of these? So that's going to be 1, 2, 3, 4, and 5. 2, 3, 4, and 5. 4, 6, 8, and 10. 6, 8, and 10. 3, 6, 9, 12, 15. 12, 15. 16, and 20, and 20, and 25. So the probability that the sum of the scores in the first 2 turns is less than 45. So either you get, the only way for them to add 45 is to have one of these ones. So, let me think. It has to be, you have to get a 25 and then a 25, or a 25 and then a 20. But that occurs 2 times. Or 20 and then a 25. That also has 2 chances. So the probability of 25 and 25, that's 1 out of 72. Okay, because there's 36 outcomes in the first, 36 in the second. 25 and 20, there's 2 outcomes out of the 72, and then 20 and then 25, that's also 2 out of 72. So altogether that's 5 out of 72. That's the probability that the scores will be at least 45. So the probability that that sum is less than 45 has equal to 1 minus the probability that the sum is at least 45. So that has to be 1 minus 5 over 72, which has to be 68 over 72. No, not 68, 67. That's it. Okay, I think that's correct. Let's move on. Question B. A ship sails for 30 nautical miles from O to A on a bearing of 49 degrees true. It then turns and sails to point B 50 nautical miles away. From B, the starting point O is observed on a bearing of 299. Okay, so that means that's 299. Show that angle AOB is equal to 70. Okay, what do we need to do? This bit here is 49 degrees. Okay, I'm going to introduce a new term there. I'm going to call it N, and I'm going to say that this angle here, angle OBN, has to equal to 360 minus 299. So that has to equal to 61 degrees. And therefore, maybe I won't call it N, let's call it Q, because there's an N here. Angle NOB plus angle OBQ has to equal to 180 degrees because co-interior angles are supplementary. On parallel lines. So therefore angle NOB has to equal to 180 minus the 61. 180 minus 61 is 119 degrees. So angle NOA plus angle AOB has to equal to 119. If angle NOA is equal to 49 degrees, angle AOB has to equal to 70. Now that took a while. I'm not sure if there's an easier way, but I got there in the end. Okay, part 2. Hence show that, show that x satisfies the quadratic equation x squared minus 60 cosine 70x minus 1600 is equal to 0. Okay. Okay, so we'll probably need to use the cosine rule here. So the cosine rule will be, because this is cosine, so I'm going to use cosine rule. We're finding an unknown side, but the angle that we have is 70, so we're going to be using 50. 50 squared is equal to 30 squared plus x squared minus 2 times 30 times x times cosine of 70. That's 2,500 is equal to 900 plus x squared minus 60x cosine of 70. Oh good, we're almost there. So now we just need to minus 2,500 from both sides. So x squared minus 60x cosine 70, or we can just rewrite it as what it says in here, cosine 70 degrees x, and 900 minus 2,500 is negative 1,600, and that's equal to 0 as required. Okay, question 3. Hence find the distance of B from O, giving an answer in nautical miles corrected 1 decimal place. Okay, so in order for us to work this out, I'm just going to use the quadratic formula. X is equal to minus B, so this is going to be positive, plus minus the square root of B squared minus 4AC all over 2A. Alright, let's do that to 1 decimal place. $51.6, and let me just make sure that the negative one doesn't work. Oh, well, we can't have a negative distance, so it just has to be 51.6. So I'm just going to write that negative, and that's nautical miles. Calculate the bearing that the ship traveled on from A to B. So we want to work out this angle. Correct to the nearest degree. Alright, what are we going to do? Okay, I know that this bit here is equal to 49 degrees. So I just need to work this bit out here, and then I can do 180 minus that to get this angle here, and then I can just add it to the 49. So part 4. Let's call this S down here. Actually, no, we need a whole angle, so I'll call it theta. So sine theta, I'm going to use the sine rule. Sine theta over x, which is 51.6, is equal to sine of 70 over 50. So the angle is equal to the inverse sine of 51.6 sine 70 over 50. inverse sine of 6 sine 70 over 50, and that's equal to 75.87 or 75.9. Now the question says we need to work out the bearing. Therefore, bearing of B from A is 49 plus, because they are corresponding angles, parallel lines are equal, 49 plus 75.9. 125 degrees. Okay, now I think I made a mistake earlier with whereas the question 18 part 1, so, and no, part 2, the probability of 25 and 25 is not 1 over 72, it's 1 out of 36 times 1 out of 36. This one is 1 out of 36 times 1 out of 36 as well, but there are 2 of them, so I can times that by 2. And same with this one. 1 out of 36 times 1 out of 36, but there are 2 ways of getting that. So hopefully that will be better. Let me just think, there's 5 lots of that, so I'm just going to times that by 5. 5 over 1296. And therefore I need to change this to 1 over 5 over 1296, which has to be 1291 over 1296. Okay. Alright, so that's it for the Sydney Tech 2019 Year 11 final exam. I hope you found that helpful. Thanks.